Hi guys, we are Roundtable Security as SU Capstone team, and our topic is intelligence, security, monitoring, and protection. And we have six team members who are Nate, Julian, Choi, Tyler, Ian, and Alec. And thanks to our sponsor, the Infosys Limited from India, and thanks to our sponsor advance like Dr. Vijay. And I think the mission of Infosys is to provide a high quality IT consulate service to meet today's growing business goals.
Okay, so our an introduction to our project and problem that we're investigating. Our cybersecurity is a collection of processes and techniques employed to protect networks, computer systems, and data from attack, loss, and unauthorized access. Security measures in an organization are usually have to be capable of responding to unknown or recurring vectors of attack in order to mitigate any loss of assets and productivity that are experienced from such intrusions. So for our project, we're investigating types of data infiltration and how deep learning can be used to enhance detection of data exfiltration events, and different techniques of detecting insider threats like UEBA, monitoring communications, and others.
Okay, so for our project requirements, we want our data to be accurate. We also want it to be reliable and modifiable. A lot of what we're searching and hoping to do now is use these machine learning and insider threat methods and methodologies, I guess is the best way to put it, and apply them to a data set. We'll also have some system operational requirements. We're doing some different machine learning, and we're going to be doing that with Python. And so we have the different Python libraries that we need to know, what version of Python libraries and the requirements that are based on those. Some of those libraries include Panda, Silent, and others as well. Another requirement is deep learning, and we also have network traffic logging that we're focused on. Also, we're doing data collection, which is proving to be the part that's taking a little bit more time in our project. We've been doing a lot of research, like we said, as well as a requirement of modeling user behavior. Okay, so our solution overview. As we've mentioned, we've split up into two groups by the instruction of our sponsor. And the first group, one of the groups is researching through data exfiltration methods, and the other group is working on UEBA, and we're trying to figure out when insider threats might be happening and different things that can signify whether or not a user insider threat is happening based on user actions within our business intranet or another type of intranet that we can get access to. In order to accomplish the task of finding a data set, we've reached out to various contacts we had. We did have some communication issues that made it and that we were unable to get a hold of Brent McMillan of the SIDSI IT lab until April 16th. In the meantime, though, we did reach out to other various contacts. We were able to talk with Stephen Yao here at ASU, one of the information assurance teachers, to get some more information on acquiring a data set and some possible leads that we could follow there. We also had some contacts from Adobe, from PayPal, and from Splunk that we reached out to find out if they knew of any data sets or other types of ways of generating a data set also. These additional contacts helped us to also understand Splunk and other methods to gather and analyze data. Some of those methods included the machine learning toolkit, MLTK, as well as Elasticsearch, Logstash, and Kibana, or ElkStack.
DNS exfiltration is a type of advanced persistent threat whose goal is to take information within a business network and send it outside into the control of the bad guys. Exfiltration comes in 4 different phases. The first phase is the reconnaissance phase. This is when hackers and evildoers search the network for points to infiltrate. The second phase of DNS exfiltration is the infiltration phase, where they exploit the knowledge they've acquired during the reconnaissance phase and enter the network. On the third phase of DNS exfiltration, which is called server staging, once the bad guys have put malicious code into the business network, they will select a server to send code that they have scraped from the host machines into their control. On the fourth phase of DNS exfiltration, called the exfiltration phase, is when the hackers will send the data from the business network to servers they control. DNS exfiltration specifically is a type of low throughput exfiltration in which data is scraped from the network, encrypted, and appended to the end of a DNS query.
So as said before, one of the processes that we've been researching on is UEBA, and that is User and Entity Behavior Analytics. It is a cybersecurity process where it takes note of the normal conduct of users. Based on noting this, the normal behavior of the users, it can detect any anomalous behavior or any instances where there are deviations from these normal patterns that the users typically have. It uses machine learning, algorithms, and statistical analyses to know when there is a deviation from this established patterns, and it shows which of these anomalies could result in a potential or a real threat. Again, we really want to emphasize on UEBA is that the fact it doesn't really track any security events or monitor any devices. The main thing that it does do and emphasize on is track the users and the entities in your system. So as a owner of a corporation, I would want to know the behavior of my employees and what these normal patterns exhibit, so that way I know that my business is running more securely. As an example, let's say there is a user within the company that only downloads 10 megabytes of file data per day. Well, let's say on another given day, this user is showing a behavior of downloading 50 megabytes. Well, that would be an anomaly, and what UEBA does is alert us saying, hey, this user is downloading too much data than what he's normally doing. We need to remediate this or make sure that there's no data exfiltration occurring. It is more easy to hack and download and obtain a username and password, but it's more difficult to monitor. It's more difficult to manipulate and show the exact normal behaviors, and that's what UEBA does for us.
Okay, so starting in January 26th, we completed our group assignments, and then a little after that, January 29th, we contacted our sponsor and met with our team together. And on February, we had an introduction research material provided by our sponsor. And then on the 11th of February, the findings on introduction materials, we sent it back to our sponsor. And then on February 13th, we split between two teams. On February 16th, we completed our project initiation document. And then on February 26th, we did an initial literature survey and we presented it to our sponsor. And on March 2nd, we finished the literature survey and presented it to our sponsor. On March 13th, we began searching for open source data for training. And then on March 16th, we finished our requirements document. And on March 22nd, this is when we first started when we first met our sponsor for the first time on March 22nd. And then on March 23rd, we researched on logarithm and Gurucool. On March 25th, we began searching for a data set. On April 9th, we turned in our signed NDA forms to Eden Fernandez from Infosys. And on April 16th, we reached out to PayPal to contact to see if they knew of any data set that we could use and also get more information on Splunk. On April 16th, we reached out to Dr. Stephen Yao to see if he knew of any data set we could use. On April 25th, it was our second conference call with BJ. And on April 26th, we actively started working with Brent to acquire a data set over summer. And here's our references. Thank you.